Hi guys, it's Tekiso once more, man. In the previous video, as you will remember, or if you will recall, we were dealing basically with the support and the concentrated load. And for us to continue, if you've got time, please go back to that video and remind yourself as to what is a concentrated load is and so on. Remember, for N1s and N2, you might even be asked as to define the following terms: concentrated load, 2 marks; uniformly distributed load, 2 marks. But now in this case, what is a uniformly distributed load then? A uniformly distributed load, it's a load that is applied over the whole or part of the beam. Let's say, for instance, on this is a beam, and there's a uniform distributed load of 2 newtons per meter applied over a distance of 8 meters. Now, very, 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 very important. If you miss that point, you won't be able to get it right. This uniform distributed load of 2 newton per meter over a distance of 8 meters. Normally, if you convert it into a point load, it should act at the center of 8 meters. That's very, very important. It should act at the center of 8 meters. So by and large, it is 8 times 2, it's 16. It's 16 newton. And where does it act? It acts at the center of 8 meters, meaning it divides the beam into 2 parts of 4. So this is 8 times 2 is equals to 16 newton, meaning the distance, this distance here is 2. That distance is 2. And then this distance from here to there is 4 meters. That distance is 4 meters. This 8 times 2 is 16, and it is acting at the center of 8 meter at the center of 8 meters. The distance from here to there is 8, meaning the 16, the distance from here to there is 4, and then from here to there is 4. Now we've got how much? We've got 3 point loads: 1, 2, 3. Now let's take moment, because you are requested to calculate the reactions at the support. Moment about A. The sum of the clockwise moment is equals to the sum of the anti-clockwise moment. That's 1 mark, guys. That's 1 mark. Now, initially we said the moment at A means that all the forces goes to A. And if you multiply that force by distance, you get a moment. Now we start with the clockwise ones, like a clock. The distance from here to there, I started with the one nearest to this point, and then this one to there, and then of course this one. So it is what? It is 50 multiplied by 2 plus 50 multiplied by 2 plus 16. 16 multiplied by 4. 16 multiplied by 4. The distance at the center of 8 is 4. This is 16 times, the distance is 2 plus 2 is 4. And then plus 30 multiplied by the distance from there to there is how much? Is 10. Is 2 plus 8. The distance from here to there, remember, is 8. So it's 2 times 10 is equals to what? Is equals to the anti-clockwise moment. The anti-clockwise moment. And the only force that is moving anti-clockwise is RB multiplied by the distance from here to point A. The distance from here to point A. And it's equals to what? It is equals to 8. Why 8? Because the distance from there to there is 8. is 8. Now 50 times 2 is equals to 100 plus 16 times 4 is equals to what? 16 times 4 I think is equals to 64. Why? Because it is 16, 32, 16, 32, 32 plus 32 is 64. Yes, it's equals to 64. It's equals to 64. Plus 30 times 10 is equals to what? It is equals to 300. Equals to 8 RB. Please guys, if you know your maths is not good, trust your calculator. The reason why I'm not using calculators, because I'm good at my mental and the basics. Now this plus this is 400. 400 plus 64 is 464. Is equals to 8 RB. If we divide both sides by 8, is equals to what? This one will cancel this one. Therefore, RB is equals to 464 divided by 8. You can use your calculator there. 464 divided by 8 is equals to what? Is equals to 58. 58 Newton. In this case, the units are in Newton because we are working in newtons. So the reaction at that support, which is 2 meters from the end, is equals to 58 meters. Remember guys, the reaction can be at any point. The reaction can be at any point. It's not necessarily they will always be at the end. They can be at any point, but it must be a support. Now let's take the moment about B. This statement, please guys, don't forget it. It's very, very, very important. About B, the sum of the clockwise moment is equals to the sum of the anti-clockwise moment. Now, the clockwise moment for forces heading to B. What is that? The anti-clockwise moment. The anti-clockwise moment is what? It's RA multiplied by the distance from there to there. Is what? It's equals to 8. There is no any other force, or is there? Is there? Yes, it is. Plus 30 times 2. 30 times 2. Why? It is clockwise. It's heading to B. RA is heading to B. Is equals to what? Is equals to 16 multiplied by the distance from 16 to B, which is equals to 4. Remember, this 16 is acting at the center of 8 because initially it was a uniformly distributed load before it is converted into a point load. So, and it's equals to 4. It's equals to 4 plus, or is there plus? Yes, is there plus? Plus 50 multiplied by the distance from 50 to that is what? It's equals to 6. It is equals to 6. Yes, it equals to 6. And then RA times 8 is equals to 8. RA plus 30 times 2 is equals to 60. Is equals to 16 times 4 is equals to 64. Plus 50 times 6 is equals to 300, guys. Very, very important. Very, very, very important. Now let's see. 8 RA is equals to what? If I take 64 and transform it on the far side of the equal sign, it becomes what? It's 64 minus 60 plus 300. Now 8 RA is equals to 64 minus 60 is equals to 4. 4 plus 300 is 304. Therefore, RA is equals to 304 divided by 8. Therefore, the answer is RA is equals to 304 divided by 8. And you get what? Let's check. 304 divided by 8 is equals to what? Is equals to 38 Newton. Is equals to 38 Newton, guys. And you've got what? You've got your 3 marks here. And you also got your 3 marks there. It might even go as far as 4. Why? Because they knew a cache here was a uniformly distributed load. So let's say you've got 8. Let's say you've got 8. I'm gonna erase this and hope you have jotted it down. I hope you have jotted it down. It's 58 and 38. 58 and 38. 58 is equals to 58 Newton. I think here it's 38 Newton. Now let's test, guys. Let's test. Very, very important. To test, the sum of the upward forces is equal to the sum of the downward forces. What are the upward forces? It is 38 plus 58. And it's equal to what? It's equal to 80. 80 plus 16. 80 plus 16, I think, is equal to 96. If my memory... No, it's 96. It's 96. It's 96. It's 96. And it's equal to what? It's equal to the downward forces, which is 50 plus 16 plus 30. And then 50 plus 30 is equals to 80, 90, 96. 96. Therefore, the left hand side is equal to the right hand side. And you got your full marks. This might probably be 15 marks. This might probably be 15 marks. The cache here, guys, very, very, very important. The cache here is a uniformly distributed load of 2 Newton per meter. That should be multiplied by 8. And it should act at the center of 8. And a uniformly distributed load is a what? It's a load applied at the whole part or only a certain part of the beam. In this case, this uniformly distributed load of 2 Newton per meter is applied over a section of the beam of 8 meters. From a beam of 10, it is applied over a distance of 8 meters. And it should act at the center. Very, very, very important. It should act at the center. Guys, please just click the subscription button there as you go through this, man, and help us this channel grow. And then basically, please, if you got problems regarding beams and so on, revisit this channel, just check what's going on, and then give your chance to grow, help yourself, remove what is so called the panic and pressure. If you study in time, you remove the panic. You will rather only be left with the exam pressure, but you will make it. See you on the next videos and mates. Thank you very much. Bye.